Alrighty, ladies and gentlemen, welcome back to the Converge stage. We are at day 2 of Switch 2025, and the theme for today is all about startups. So coming back, we're going to go into a deep dive into practical application, vertical AI in action, video intelligence, finance AI, and memory-centric systems. So as AI adoption matures, the competitive advantage is rapidly shifting from general purpose models to specialization, the development of tailored intelligence for specific domains. So powered by NTU, this upcoming session features a series of founder-led demos and pragmatic discussions on this exact transition. You will see firsthand how these innovative AI startups are collaborating with enterprises and public sectors to bring scalable, secure, and context-aware intelligence to life. So without further ado, I'm going to welcome the first speaker on stage. Please put your hands together for Kelvin Kok, CEO and co-founder of Kukri AI.
Hello. Very good morning to everyone. Happy to be here to talk about the topics of video intelligence. Just to begin, a very brief introduction of my company, Kukri, a Singapore-based deep tech startup. We work on the next generation AI on no-code video analytic. We build proprietary video language model and also pioneering the advancement in the area of test time learning. So, video intelligence. From user point of view, video intelligence literally turn camera footage, those CCTV around us, into automated insights and alert, enabling smart real-time monitoring without the human supervision. Typically, in video analytics, we can perform the following functionality. You just treat it like CAMS, like the camera. C for compute, the ability to count target. A for alert, the ability to detect, recognize, identify, and send notification. M for monitoring is not just monitoring, it's also about tracking of targets. So there's a dotted line there. Everything on the left of it is operating in live, near real time. And then in the post occurrence, that is where you do target search by NLP for analytic. So essentially, these are the functionality for the user's perspective. Now, from technical perspective, video intelligence leverage on advanced computer vision, as well as deep learning model to detect, recognize, track, interpret object, and human behavior. So in this diagram, what you see at the top is human vision. So the eye see the bowl of fruits, and then the brain process it and know that these are the object. In computer vision, essentially the eyes are replaced by sensor, typically camera, and then the AI is the computing models, and these are connected together with different networks, and that is where computer vision is able to recognize the targets. Typically, computer vision works through a full suite of analytic, from human analytic, traffic, footfall, patterns of life, object process, predictive analytic, compliance, and so on. So I'm going to show you some example of my companies, some of the projects that we have been working on. The first one is in public safety and security. This is typically a project that we done with the Malaysia Police for Taipusan early this year at Batu Cave. 1.8 million people turned out over the 3 days. So we're using the AI to help crowd control management as well as access control. Now, this is estimating of crowd with an accuracy of about 95%. The next video that I want to show you is about precision count. If you look at the gate that has the table box, right? The AI already counted 19 person is queuing into entering the gate. As the passenger load up, you see the number of counts of the queue start to reduce live. And it's not interfered by passenger that is coming out from the train. But what is important is that when the AI detected there's momentary halt of passenger that couldn't go on board, it says that people didn't go on board, there are 6. If you count carefully, there are 6 of them. If you look at that man, now he is unloading his bag. That action actually triggered the AI to say that he's going on board, and the number of people that didn't go on board is 5. So as the gate closed, for this particular gate, there are 5 persons who couldn't go on board, and we can actually consolidate live across all the gate, and the train operator will know how many people couldn't go on board when the train come in. That's precision count. And then of course you can use video analytic in this case for human analytic for billboard advertisement. You not only look at the footfall computation, you also look at the gender profiling in both weekday, weekend, daytime, nighttime. With this information, now the advertiser can calibrate the kind of advertisement targeting specifically to the target audience. Of course, this is illegal now, and then detecting vaping is something very straightforward. I hope this is not happening in Singapore school. But we can detect smoking and vaping fairly easily using computer vision. In this example here, is tracking about moving human targets. So in this example, my guy load up 2 of my photographs. If you can see CCTV A, when I appear even with the back facing the camera, the AI is able to detect, recognize me, and track me throughout the journey up to the 2nd floor. When I come to the 2nd floor, along the way, I actually put on a cap, and the AI continued to detect and recognize me. And then I went into Starbucks, and then I came out from the 3rd floor, and I changed my jacket from blue to gray, and the AI continued to recognize the person. So, bearing in mind, these 4 cameras, there is an air gap, meaning the cameras are not overlapping in coverage. This is tracking a movement target based on input of image. In the next example here, now we want to track moving human targets based on text prompt. So in this example, for example, that you don't have the photograph of the target, but all you know is, for example here, woman with pink luggage. Now the operator key in this text prompt and activate the AI. And when the AI detected a character that matches with this text prompt, in this case, a woman with pink luggage, it will recognize, detect, and track. And when she enter into the other area, in CCTV B, when she reappear, it will also continue to track the moving target. The important thing about this aspect of AI detection is based on vision language model. Vision language model essentially is a multimodal generative AI model that capable of understanding, processing video, image, and text. It has the power to do video summarization, video extraction by text, and also doing visual Q&A. In this next example here, what we have done is that we have uploaded a video from Channel News Asia at the top right corner. And then now we key in text to find the content within this video. First example is a white sport car. So once the text is keyed in, the AI will comb through the whole video and find the scene that has a white sport car, detecting it quickly and accurately. And then, for example, man wearing a cap. So again, the AI will comb through the video, and if you can see, the man wearing a cap is actually coming from the side mirror. So it's a very fine-grained target that is able to detect. The third example, Mont Blanc. We know the brand Mont Blanc pen, right? So Mont Blanc wallet, you key in, again, it comb through, and it can find the scene that has a Mont Blanc wallet on the left. You can see it's lying on the table in the sideway. And that's a Mont Blanc wallet, right? And then maybe the last example for this video language model is you key in a car plate number. When you key in the car plate number 6167, he combed through the video and pull out that particular scene that has this car plate number, in this case SNE 6167. So this is another example of how VLM are being used in real life. The application, for example, in a shopping mall, if you have a little boy or girl went missing, now you can actually go to the security office and key in the description of the boy and girl and activate the camera to find if he appear in any of those cameras. Now, about object analytic. This is one example of object analytic. You can very simply look at traffic analytics, the number of vehicles coming into the city and the number of vehicles leaving the city both in the day and night. That is pretty simple. And a lot of all these are based on YOLO, which is a popular object detection model. However, in this model, there are some fundamental limitations. The limitation, they are struggling with detecting small objects. They are fixed aspect ratio challenge, difficult to have overlapping object detection, and they are sensitive to image quality. And again, it has a high false alarm rate. So this is the fundamental problem of YOLO that we face today. What Kukri, my company, have done, we have developed a video analytic model called Spiral MLP based on multi-layer perception. We actually published this paper in the WCV conference in the US early this year. What does this MLP does is that it streamlines image processing, work on few shot learning, require very few parameters to train the machine, and then it run on embedded device and it outperform most of the traditional model in speed and accuracies. Using this model, what we have done for one of the project is in the aircraft engine inspection. You know, each time when the aircraft send in for MRO for inspection, the engineer actually insert a boroscope to, based on human, to detect defects such as cracks, erosion. Now the AI is augmenting this process and helping the engineer to detect these defects, which is very, very small. You can't use YOLO to do that. So this is one of those examples that using Spiral MLP. We also work on a smart indoor farming to detect the stress of the plant stress growth. And then when the AI is able to detect that, it automatically trigger the nutrient and the water 24/7 without the human intervention. Using the same model, now we can detect, recognize, classify, and track flying drone from distance. So again, the application of Spiral MLP is cross-vertical. It's not static in one single industry. In this final example that I want to show you is a project we did in China. The problem statement with this factory is, each time where their product leaves the factory, there's missing components. So what we do is that we install camera, AI empower it. Each time where the operator or the worker insert the SKU, the item into the box, the AI will detect and turn the red color item into green. So the whole list are those SKU in the box. So when finally reach the last part of the belt, the QC officer now just look at the screen. If these boxes are all green, it's good to go. If there's a missing part, he knows exactly what is missing, and he can now address it before it leaves the factory. Having said that, this solution has an inherent problem. What is the problem? The problem lies in factory like this have thousands and thousands of SKU. So it is not possible that each time when they have a new SKU, they come to us and then we train the machine for it. So for this, we have developed a solution called test time learning. What's the difference between traditional machine learning and test time learning? Traditional learning is the model learned only during the training and label data sets. After the training, the model actually frozen and deployed. For example, if you ingest 10 knowledge points into the machine learning, he learns. But when you want to ingest the number 11 knowledge point, he can't learn, but you have to retrain the entire model. That is the current limitation of machine learning. In test time learning, a paper that we have published in the ICLR, it adapts learning during inference. You can now make use of the incoming test data and it learns itself. In other words, it learns on the fly. You have 10 knowledge points that the machine already pre-learned. When you insert the number 11, it just pick it up just like human being, right? When we learn something, we don't have to relearn the whole package together. This is test time learning. So, in a quick summarize for this morning's presentation, where is video intelligence moving to? At the base level, that is where computer vision is. CV extract and interpret visual information from image and video, and it can do detection, tracking, segmentation, and so on. The next layer is the multi-layer perception. MLP actually helps increase the capability of learning complex pattern for classification, and actually it serves two purposes. It removes a lot of false alarm, And secondly, it can now has the capability to detect very, very small objects like those defects that I show you in the aircraft. And the third level is, of course, the VLM that link visual content with natural language. The power of VLM here is that now you hand the flexibility to the end user. He can now, based on NLP, to instruct and empower the AI for new detection, new requirement of detection. That's VLM. And then the next level, which is now, if you Google this term, test time learning, is at about TRL 3 to 4. It adapts during inference, and it can allow real-time learning on the fly. So this is where video intelligence is moving towards the new discovery at the 4 level. So let me conclude this. Video intelligence is applicable across all industry. As long as you have large video data sets, as long as you have a lot of CCTV, it will make your life, your work simpler, smarter, and safer. So with this, I thank you for your attention, and I yaw back to the stage to the host. And I'm happy to connect with you for any collaboration or any exchanges in this area. Thank you again, all.
Thank you so much, Kelvin. That was a really fantastic demonstration on the latest innovations with video intelligence. Now, coming up, the next few sessions will be very similar to this. There will be demonstrations and also discussions. So I really hope that you will stay with us all the way till the end. So the next showcase the latest innovations in finance AI. Please join me to welcome Kelvin Tan, Chief Technology Officer of Pines AI.
That's right. Yeah. Hi. Mic check. Okay, good. So hi everyone. My name is Kelvin. I'm the CTO and co-founder of Pines AI. So it's nothing to do with beer. It's just where the place that we were drinking beer, and then we came out with this whole AI idea. So we just decided to call it Pines. I'm just going to start off with one fact that was found by MIT. 95% of Gen AI projects fail, and only 5% made it through to production. So you can imagine that the failure rate of this is very high. But we're going to change that. 100% of all of Pine's customers, Gen AI products, make it into production. And I'm going to tell you the reason why. So MIT calls this the Gen AI divide. You have 95% on one side that leans on very generic tools. They are very slick. Usually if you see that a tool is very slick and you have all these automation connectors, and like you can start on day one, simple tools for simple people to use, they're usually very brittle. Like you demo something, it works, goes into production, that's when it starts to fail, when the complexity stacks up. Cannot connect to enterprise databases. There's no way to talk to or to communicate with your legacy systems. So on the other end is your 5%. They embed Gen AI into high-value workflows, and they integrate very deeply. So do we have a framework, or do we have a platform that helps to integrate into workflows? Capture this 5%. So this is what Pines AI is all about. So we are generative AI for insurance on the correct side of the divide. And correct side based on the 100% of the POCs that we brought through into production with 6 customers, enterprise customers, spanning across Sun Life Insurance, Hewlett-Packard, India's 7th largest insurer, Aditya Birla Capital, as well as Sun Life Mutual Fund. We also have a research lab with SUTD, so that's where I'm doing my PhD with, and collaborations with NTU as well. So we're very research-backed. Academia, we have reached into academia, and we actually do product-led research, not just research for the sake of research. We look at what problems we have today, we work backwards on what the research we need to do. One of such things that we do was to pre-train our own small language model, 1.5 billion parameters. It's out on Hugging Face. If you search 1.5 Pines, 1.5, which is the model parameter size, and in Pines, that's us So I'm going to jump to demo, but I'm just going to stop and pause at this juncture to give you this QR code. So if anyone who's interested to get your GenAI workflow working 100% of the time, please scan this, drop your email and your name, and we'll get back to you. Okay, I still see some cameras scanning, so this is the important part of the talk, so I'm going to leave it hanging for a bit. Okay, now to the boring part, demo. So GenAI workflows that integrate with what you need is starts with a front end, a simple enough front end for people to build applications on top of, something that your business users can understand. You want to drive adoption, because if you build applications that people cannot use, they will not adopt it. And they also need a frame. Powering all of this beneath is a framework that takes care of everything that you need for GenAI application building. Orchestration, multi-LLM, agent framework, tracing, auditability, everything is there. I'm just going to walk through a day in life of an insurance agent or financial planner. So I just received a call from one of my clients, and he's saying that, oh, I'm trying to get a motor insurance, I'm trying to sell to him, but he said that someone else has a better motor insurance. So this is in the insurance space, very popular category of technique called objection handling. So objection handling says that if I try to sell Allianz and someone tells me MSIG is better, I will not be able to better the parts that they are good at, but I get to find something else that I am better in and bring that back to my client. So instantly I get to look at what are the differences between my product and the object, basically what the client is saying, and then I would say that I have roadside assistance, like for up to 12 months, if your vehicle is less than 12 months old, so on and so forth. I could also look at whether my driver's age, in the age category, I'm better. So this is objection handling. The other way of doing this would be to go into the website of MSIG, which is my competitor, go through a brochure. That takes me very long. I just did objection handling in less than 1 minute. For insurers, a big part of their life is to deal with claims. So how do we build in GenAI workflow to help with claims management? A lot of things that I'm doing on a day-to-day basis in insurance as a claim administrator is to look at very boring documents and then try to figure out what's going on, compare them with the existing legacy system, inputs in the legacy system, make sure that the name matches, make sure that the signature matches. But all of this we can do with GenAI. So let's just say that, and this platform that we have, PyCI platform called AutoThought, it works on top of, it's designed to work as a standalone system, but at the same time it can work on top of legacy systems, building connectors into your existing workflow, and then pulling data out of it into a GenAI automation. So down here, like the first thing I get is a claims summarization to know what's going on, how much money, what's the claim amount, what's its incident date type, and all of this are information pulled out from documents that are in all shapes, ways, and forms, like hospital reports, police reports, things that you will manually have to copy and paste and put into. Even something as simple as incident date is different in different claims. It could be the date you're admitted in the hospital, it could be a police report. So GenAI does all of that for you. And then we have the discrepancy, the rule engines, which are derived from typically what the insurer call BRD, business rules. And the workflow there is that it will be turned into a GenAI checklist. Not all of them needs GenAI to power. Some of them are algorithms that GenAI will create to look for specific string matches. So let's just say that I have a particular police report that I'm putting in. Down here, I'll just upload this, and then I get to attach the files. So later on, we say that we need a police report because this one here involves someone maybe falling down and another person causing that fall or whichever. I can attach this report, and then on the right hand side, what I could do is that I could say, can use report for me. So this, and in a typical claims scenario, you have like somewhere between 30 to 50 pages that you have to go through just to figure out like what's going on. So we get to see that all the information is here just in like 10 seconds. Now we're down in claims. I want to engage I'm a financial planner, right? Insurance agents, financial planners, more or less synonymous nowadays. I want to engage my clients. So I want to write better emails. Gen AI can help me with that. Sometimes I want to open, it's a new client, I want to talk to him. What do I talk to him about? I have some CRM, the information about him. I know his LinkedIn, I know his social media. Maybe he just came back from Shanghai or Japan. Help me create some small talks. And on an ongoing basis, I may want to engage these clients. So some of the interesting topics that people like to talk about nowadays, so we can open conversations into buying financial products, for example, is about Donald Trump's tariffs, right? Hurricane Melissa is one, new one, but then Donald Trump tariffs. So then how do I use information and news without reading them and summarize it into something that I can send, especially to my high net worth individual clients, right? So I have a template, the AI helps me create that. And then I have ability to look through the web to find information, or I could use information that the insurance companies already buy, especially from all the Morgan Stanley, JP Morgan, or in the likes. I could also use my own sources. So I'm just simulating this as a flow. So I can generate something very small, snippets of information that I usually will take roughly about 1 hour or so for a financial planner to send out. This also works for bank relationship managers selling financial products. Now, Gen AI can do this for you, right? If you go to ChatGPT, of course the privacy angle is not there. We can deploy everything on premise so that it can connect to private databases as well as use proprietary information that an insurer purchased. That's one part, but the second part is that all this looks very generic. Now, the key down here is that whatever you send out as a financial advisor, you have to verify the information, and it's according to the FAA Financial Advisory Act, you could be held liable if information is not accurate. So you want to be able to trace the information. We're going to talk about like 25%, 10%. We're going to talk about like this $2,400 as a household income price impact. Where did that piece of information come from? So that I can verify it before I send out. So let's say we've verified this information is ready to send. I could just export it and then send this over to my client. So we did most of on a day-to-day work that an insurance agent or financial planner need to do in less than 10 minutes. That's pretty much the tool. And I'll just go back to the main page to show you what other applications that we have. So all of this is available right out of the box for an insurer to use. So if an insurer is thinking about Gen AI workflow, please do reach out to us. If you're also an independent financial advisor, I think this is a great tool for you as well. The subscription doesn't start at a lot of money. If you need an on-premise deployment, we can do that as well. So I'll just go back to this slide again. This is our QR code. Please scan. We're also we also have a booth all the way out to the back, closer to the shopping area. So on the way out, before you go shopping, you can just visit us and see if there's anything that we can help you with. That's all I have. If there's any questions, I'm happy to entertain them after we leave this stage or at our booth. Thank you very much.
Thank you so much, Calvin. Now, like what he said, if you would like to link up with any of our speakers today, you will be able to find them hanging around Switch 2025. Now, coming up next, we have another insightful and great demonstration. And to share more with us about memory-centric systems, we have Dr. Jake Yang, Chief Technology Officer of Sinno AI.
Okay. Hello, everyone. Okay, cool. So people, you can see the screen. The voice is good. Okay, can. Hello, everyone. I'm Jake Jinkang Yang from Sinno AI. I'm the co-founder and CEO. I just graduated from Nanyang Technological University, PhD degree last month. So I just start full-time in the new company. We are Simple AI. We built multimodal contextualization system for AI agents. So this is 2025. 2025 is the year of AI agents. You can, like, everywhere you walk around here in the switch, you always hearing the people talking about AI agents, right? So, but here is a real question. Here is the real question. Have you really tried AI agents? Raise your hand if you really tried AI agents. Okay, there are fewer people raising hands. Good. But another question is, can AI agents really solve your problem? Raise your hand if you think the success rate is beyond 50%. Raise your hand. In your cases, if the 50% of the use case can be solved by AI agents, seems not many hands. So, okay, one hand's good. Generally, that actually matches what the AI agent company show us in their report. So, only below 50% of the AI agents can have a success outcomes, and they also say that 30 to 50% of the failure comes from one single issue, which is lack of users context. So let's understand what is lack of users context. For example, last month I want to book a flight ticket back to my hometown for a vacation last month. Okay, so I asked an AI agent to help me book the flight. So I assigned the task to him, to the agent, and the agent come back to me, where is your hometown? So I type in, okay, my hometown is blah, blah, blah. And then it asks me again, like what's the budget you are targeting, and what date, and what time. So it going to back and forth. And there are like 10 rounds of the question and answering. I just like sitting there typing, and yeah, round by round. I was thinking, like, if I ask my parents or my partner to help me book the ticket, they will never ask me to answer these questions. And like I'm typing, and in the end, I thought, okay, it almost to the end of this session, my ticket should be booked, but eventually the AI agent asked me a ultimate question: what's your name? So yeah, so I almost threw my computer away, but yeah, so that is what is lack of context. The lack of context actually means like you need to communicate with the agent several times to give the context to the agent. And yeah, so that is what exactly Simple AI wants to do. Simple AI wants to stand in the middle of the human and the agent. So we understand users' data, and we build the user's memory or user's context, like users' preference, users' habit, users' data, everything with our system. And human no need to communicate with the AI agents anymore. We take the responsibility to talk with the AI agents. People just sit back and look at the Simple AI is like sharing the most important knowledge of the human rather than like give all the private information. So we are talking with AI agents, and the human just free up. And there are much more use cases that we can think about. Like if we want to suggest a birthday gift for your girlfriend, like for a classic agent, the agent do not know who is your girlfriend. So it's gonna give you a very generic answer, like yeah, send her flowers, very stupid, very boring, right? But with Simple AI understand from your conversation with your girlfriend, and from maybe your like email or your own preference, like what style of the human you are. So give you a very customized the suggestions. Like they on the Symbol AI can understand like you bought a book last week and an iPhone last month, and her idol gonna go to Singapore, so better book a ticket for her. So this is the intelligence behind, rather than just like agents just act what we tell them to do. And other examples like booking a flight, just like what I said, if you book a flight to your bosses and you through your email, you can understand what your bosses like their preference. They like, for example, Singapore Airlines and all the details. So we can capture it and store it in Symbol AI so that Symbol AI can communicate with the agent. And what human need to do is just like a supervisor to say, okay, that's fine, good job, to click the confirmation, or like do some editing on the final answers. And the third use case is for filling the missing financial data in the Excel file. So in the working space, your working directory or your computer is your memory, is your working memory. So AI agents, if they cannot get the data of your own computer or your data, they have no context. So if you want to fill the table, the source of the data are from your own data or your own knowledge base. If the AI agents cannot access to it, they cannot finish the task for you. So here we can show the demo of what to compare the classic or standard AI agent with the agent with Symbol AI. So you can see with a classic AI agent, need users to provide all the context file manually into the platform. So you need to know where the data comes from. So you need to find exactly the file, where the file is, and drag it in. And then it requires many processing to understand like what the purpose and what is missing in the Excel data, Excel file. And it's reading, writing code to reading. It takes time. It also takes credit or takes token, right? It's expensive. And then it's reading the file that I uploaded one by one. It does not, so, and it takes a long while to read all the files. And eventually it turns out like it's thinking and it say, okay, I cannot find the results. So the problem here is like without context, you need to go through all the information from scratch. And it takes 7 minutes and there's more than $3, but it turns out, okay, it's a failure. But with Symbol AI, we already build the context of the users, and we understand all the information in their computer, so that whenever an agent want to ask, or the user want to ask the agent to solve a problem, the Symbol AI the AI agent just asks Symbol AI, okay, what's the purpose of the user, and it will give you a green box here, like what is missing in the context, what is missing in the Excel file, and then agent only need to ask Symbol AI again, like the exact number of some blanks in the file. So it's just like we are in the middle of the agent and the human just watch there, sit back and watch, and we are communicating with the AI agents. And also the data and the context can be referenced. We have citations so that we can like fill in the blank one by one. So with Symbol AI, with this contextual, we can have the job can be done within 2 minutes, and the cost is below $1. So in sum, with Symbol AI, the job can be finished almost like 5 times faster, and it's like 5 times cheaper, and most of all, it completes the task, and it will cost the higher user stickiness. So that's the value we bring to the AI agent. And how do Simple AI works. We build the contextual intelligence layer that continuously understands users' local file, conversation history, and user behavior. All of them are building with the 3 important blocks with profiling memory, multimodal embedding, and procedural memory. So all these 3 blocks, they are involving with the people using their local machine, and when they upload and when they change their files, they are evolving into within the system. And then whenever a user actually have a query, go through this process, we can have a query specified context. And another very important part is the chance and provenance layer. So we have 2 solutions, one is on device and one is on premise or on cloud. So on device, we can get all the information of the on device users on device, but only give the most important one, and we are not relieve the confidential information from the user's context, so that the AI agent, what AI agent gets is the critical but not sensitive information. So here is the API we just developed, and hopefully, if you are interested in, please scan the QR code and try. Here I briefly show you how our platform looks like. So yeah, we have the console here. You can get your API key. The internet is not good, and anyways, I can describe. Here you can have a dashboard, and you can have so you can create a API key here. And with the API key, we have a very well-run documentation so that you can play with it with uploading the file, and you can ask any questions you want, and it will give you the context, the most relevant context. And you can try on your own, so that hopefully it will help your AI agent to finish your job. So the QR code again. We have free credits so that you can use. And later, we are actively developing, and we are integrated into many different AI agents, so that we will show many use cases, so you can also raise up your own. So to the end of my sharing, it's so lovely to meet you all. And we are a startup company that is just born this year. And we are spin off from AM Lab at NTU. We are an AI lab that have many, almost 100 of the researchers, AI researchers. And we have many great work that accepted and cited by big companies like Google, like OpenAI. So we are a strong team, and we are focused on AI. We hope that we can use our AI technology to really help people in the real world. So thank you, everyone. Hope you enjoy, and please visit our website. Thank you.
Thank you so much, Jake, for the demonstration for us. Now, ladies and gentlemen, just to catch you up on what's happening around Switch 2025, as we're going to go on a break, and Converge will be back at 1 p.m. In the meantime, if you would like to head over to the global stage and also meet with the market access partners, please feel free to do so. That is going to happen all the way till the end of day 2. Otherwise, we're going to take a short break, but when we come back, it will be a session powered by SUTD. So we definitely look forward to seeing you later at 1 p.m. In the meantime, have a good lunch if you're going out, and I will see you shortly.